All right, so now I'm going to show you the proper way to deal with this particular situation. So we're going to reduce the number of dimensions from 4 to 3 and yet somehow produce the exact same model. And I'm going to show you how to do that. And it starts out with a different map between the now 6 generators of our complex three-dimensional space and the 4 space-time generators, which are the gamma matrices. And you can see them here at the top. Okay, this is a way of doing it. Now the brackets, by the way, are just a way of writing the commuter. So this is Q0, Q0 dagger minus Q0 dagger, Q0. So it's a shorthand for that. If it were a plus, then it would be curly braces. And that comes with quantum mechanics. Using these gammas, you can see how they relate. I gamma 0, 1, 2, 3, 1 and 2. Gamma 0, 3, just the zeros. I gamma 1, 2 contains all 3. That's the pseudoscalar element. I want to say that once you do this, you can then, what's very important is to look at the gamma 0, 1, 0, 2, and 0, 3, because that relates to the vector that we're going to project out of this. You can see that you get a 1, 1, 2, 2 here, and it turns out that any rotation in the 1, 2 plane leaves that unchanged. And then obviously the other elements are just related to 0, so they're also unchanged under a rotation in the 1, 2 plane. And that's very important because that's what gets us SU2. So going over here, you now have a vector. This is different than we had before, but it gives the same result. It's also very close to what you're already used to using column matrices for psi, but now, of course our psi now are fully realized objects in this Clifford algebra. And as before, you have a different transformation on the left versus the right psi, and this creates a requirement on, or a limitation on L and U based on what we need out of this. We need this to be a vector. So the scalar parts of J mu there are a form of vector in spacetime. And so the L transformation here has to be a Lorentz. But it turns out that you also get this extra room for any rotation in the 1, 2 plane, and that gives us the rotors in 1, 2, that gives us SU2 cross U1. And then U is just unitary, that's it. And since there are only 3 dimensions, that gives us SU3 in its entirety. So here I've written 4 out of the 8 possible rows based on projectors that we can create out of the generators of our complex space. And I've labeled them accordingly. So you have the neutrino here in psi 1, the electron, which is the same format, but it has a Q2 dagger in it. So that means that any rotation in the 1, 2 plane is going to take only these 2 and transform them to only these 2. That's how that works. Now I can write all that out later. But that means that not only do we get SU2 and what we expect, but it's chiral and only interacts with left-handed particles. You have the down quark, or red down quark here, and the red up quark, green and blue. You can see the blue is got these flipped. There's also the other 4, which are the antiparticle versions of these. Okay. This all works. You can walk through any interaction. Remember, U rotates on the right, so what U does is it switches these around with one another. But this one here, which is the lepton one, doesn't allow for rotation the way that it's written. All rotations cancel. So the only ones that rotate this way are these psi 7, 6, and 4, and those are the colored quarks, hence SU3. You'd say, okay, well that's great for 1 generation of particles, because that's what we can fit in here. What about the other 2? Well, there's a rule you gotta remember, which is that the labeling of red, green, and blue is arbitrary, okay? We just need 3 states. I've labeled them this way, but technically they could be any label. So how does one get from red, green, and blue to green, blue, and red? Or blue, red, and green, which would be a shift of everything. So all 3 possibilities are covered. And the answer is it's equivalent to shifting the generators of our space. 0, 1, and 2, 1, 2, and 0, 2, 0, and 1. So when you think about that, what that means is our gamma matrices that we chose up here, well, that's only for one generation as configured. I can rewrite these by shifting around my indices to get a total of and a maximum of 3 generations of particles. So each generation uses a different set, a different projection from the complex dimensional space, 3 complex dimensional space down to space-time. So that's a way of thinking of it. The different generations of particles are really the same thing, but projected back to space-time differently. That's all there is.